Hello, everyone. I'm just going to run through a few of the integral test problems from section 11.3. This is a problem session, so I'm not going to do too much lecture, just problems. So let's try testing this series for convergence. Okay. So for this section, we're using integral test. So if my improper integral with bounds 1 to infinity, same as on my series. If this integral converges, my series will converge. So I need to figure out what this integral is. And instead of k's, I need to turn the terms of my series into a function. So whatever my index is, whether it's k or n, I need to turn that into a function of x. So I need to write this stuff inside the integral as ex e to the negative x dx. And now I need to find this integral. Okay, so if you looked at my steps that I laid out last time, this would be, step one of my process. I've found the function that matches up with my terms of my series, which is usually just as simple as replacing the index with x. Okay. Step two, I should actually, before I even try and integrate, I should check that my function matches all my criteria. What do I need from my function x e to the negative x? I need it to be positive, continuous, and decreasing. Okay. I should check those. Okay. How can I check those? Let's say positive. If x is greater than or equal to 1, okay, that's going to be positive. And this is going to be positive. So when I multiply them together, it's going to be positive. Okay. What about continuous? Well, x is a continuous function. It's a very simple continuous function. What about e to the negative x? That is also continuous. Think about its graph. What does its graph look like? Something like that. Okay, and so we're multiplying two continuous functions together. That's going to be continuous. What about decreasing? To figure that out, I need to look at the derivative. So I take the derivative of x e to the negative x. Let's see, what would that be by product rule? That would be e to the negative x minus x e to the negative x, right? All right, so is this negative for x greater than or equal to 1? Let's see. Yeah, it should be, right? We want this derivative to be less than or equal to 0. We don't know that's the case. Is e to the negative x less than or equal to x e to the negative x? Yeah, if x is greater than 1, this is going to be true, so this is going to be true. So my derivative will be negative, which means my function's decreasing. Okay, so I've checked all my criteria. Boom. Step three is to actually compute the integral, and let's do that on a new page. This is an improper integral, so I turn it into a limit. Then let's see, I need to do integration by parts, it seems. So I'm evaluating this limit. Let's see. When I plug in t, I get this. When I plug in 1, I get this. Okay, so this is just a finite number. Let's see, did I do that right? I pull out the negatives. Yeah, that looks good. And then, so this is just a finite number. The question is, what is this limit here as t goes to infinity? Well, the limit of this piece should be 0. The limit of e to the negative t as t goes to infinity, that's 0. What about this? The limit of negative t to the times e to the negative t. What's the limit of that? We can try, we could do L'Hopital's rule on that, but the limit of this should be 0 as well. So my entire limit should be 0, okay? Excuse me, the limit of this piece should be 0 plus this finite number, okay? So my limit should just be 2 over e, okay? So that means my integral is convergent. My improper integral is convergent, okay? So what does my integral test tell me about my original series? It tells me my series should also be convergent as well. So my original series, k e to the negative k, should be convergent. Again, this doesn't tell us anything about the sum, but we do know it's going to be a convergent series. All right, let's try another one. How about this series starting at 2, 1 over n ln of n. Okay, so again, I convert this into a function of x. So just replace my n's with x's. Okay, so I want to consider the integral from 2 to infinity, 1 over x ln of x. Okay, so maybe that would be my first step, turning this into a function. Second step, checking my criteria. Is it positive for, let's see, x greater than or equal to 2? Ln of 2 is going to be positive. Let's see, ln of 2 would be a positive number. It'd be slightly less than 1, but it's still going to be positive. And let's see, what about x? If I plug in 2 for that, yeah, it's going to be positive. And the same thing's going to be true as x gets bigger. So yeah, this is positive. Always positive on, remember, we care about the interval where we're integrating on. It's positive on 2 to infinity. All right, is it continuous on 2 to infinity? Okay, we got that one. Is it continuous? Well, let's see, what could go wrong with this? We could have a negative number in the ln. That would screw things up. But let's see, we're starting at 2 and going upwards, so that's not going to be an issue. Or we could be dividing by 0, but again, that's not going to be an issue on this interval. So continuous on our interval. Decreasing, to find decreasing, we need to show the derivative is negative. So what is, let's rewrite this as x ln of x to the negative 1. What's the derivative of this? Be negative 1 x ln of x negative 2 times derivative of what's inside. That'd be ln of x plus 1. Okay, so let's see. Is this going to be negative on this interval? Well, let's see. This piece on the interval 2 to infinity, when I plug in any number between 2 to infinity in this, okay, this is going to be positive, right? Because as we said earlier, ln of 2 is going to be positive, and it's only going to get bigger as we increase x. Okay, so that's positive. What about this? Same thing's going for this. Ln of 2 is going to be positive, and it's going to get bigger as x increases. And then x is positive as well on that interval, so this term's going to be positive, even though it's a fraction, right? This is 1 over this squared, but it's still going to be a positive number. And then we're multiplying it by a negative number out front. So we have a negative times a positive times a positive. That's always going to be negative. So my derivative is always negative on this interval. So my stuff is decreasing, just like I want it to be. Next step, we can do the improper integral. I set it up as a limit. How can I integrate this? This looks like a u sub. Let's try u equals ln of x, du equals 1 over x dx. So du times x equals dx. So let's see. Let's not bother changing the bounds. I would end up with 1 over u. The x would cancel, right? With when I replace dx with x du. So I'd end up with this integral. I integrate it. Okay. And I should be evaluating it at bounds. And then I could undo my integration, or excuse me, undo my substitution. And it's going to be a little funky. I'm going to get ln of x, and I'm evaluating that from t to 2. Okay. So let's see. Let's go to another new page. All right, so I'm evaluating this limit. Okay. So what is the limit of this? What's the limit of this whole thing? Okay, this is just a constant, right? Is it defined? Let's see. I take ln of 2. It's going to give me some positive fraction, and then I take the limit of the ln of that. Excuse me. I take the ln of 2. I get a positive fraction, or positive decimal number. And let's see. I take the ln of that. That's again going to give me, well, it might be a negative number, but it's still just a finite number. Okay, so we have finite here. And then, okay, what's going on here? As t gets really big, ln of t should get really big, right? And then the ln of that should also be getting big. Maybe it's getting big very slowly, but this should go up to infinity. Okay, so the limit is infinity. My improper integral diverges. So my series diverges. All right. So we've seen two cases now. We've seen a convergent series using the integral test and a divergent series. I think the integral test is fairly straightforward. It's really just about whether this improper integral converges or diverges. So I think that should cover all the cases we need for this section. Let me know if you guys have any problems. I'll be more than happy to come and make some more material on this if you need it. But otherwise, that'll wrap up integral test.